beautiful people, and welcome. In this video, we are talking about geometric sequences. Now, if you haven't watched the arithmetic, we did that first. Now we're jumping into a geometric sequence. So let's go ahead and jump into it. Disclaimer time. As always, if I make a mistake, I am human. That is okay. Let me know where the mistake occurs so that way I may learn from it. All right, let's go ahead and define what a sequence is. Now, we already did that in the arithmetic video. However, let's go ahead and define it since we are in geometric sequences now. So a sequence is an ordered list of numbers. It's just a list of numbers. It doesn't have to be in any specific order. It just, the numbers are an ordered list of numbers. Now, what's very specific about a geometric sequence is that the list of numbers contain a pattern. Now, this pattern is different than arithmetic, obviously, but the pattern is very specific to multiplication. So the geometric sequence contains a pattern where a fixed amount multiplies from one term to the next. So how would that look like? Well, let's say you have a pattern, and I'm not even going to tell you what those numbers are, but let's say you have a list of numbers. There's a number, there's a number, there's a number, there's a number, and blah, 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 and it goes on forever. So what the geometric sequence says is that to get from this number to this number, you have to multiply by something. To get from this to this side, you have to multiply by something, and to this side, you got to multiply something, and you keep going on and on forever. Now, because we're multiplying, that number of which we are multiplying by, I'm going to call it little r, that's called the common ratio, and this one here. Common ratio is indicated by a lowercase r, and what the common ratio is the pattern. So what is the pattern? What are we multiplying by? Now, there is another way of finding the common ratio that doesn't involve multiplication. I'm going to show you that. So sometimes it's easier if you can't see the pattern. Sometimes this helps with fractions. But if you can't see the pattern, what you're going to do is you're going to take your right number, you're going to divide it by your left number, and that's going to be equal to your common ratio. And you want to make sure that you have a pattern. So don't only do this once with one or two numbers, one group of numbers. Do that for all of them. For example, here's going to be your right number. This is going to be your left number. Now, then I take two numbers that are next. So now this is going to be your right number, and this is going to be your left number. And we do it one last time. So this is going to be your right number, and this is going to be your left number. Double check, make sure you have a pattern. Just like we're double checking every single time we're multiplying, make sure you have a pattern when you're doing division to find the common ratio. Now let's go ahead and do a quick example here to find the common ratio. So how would we do this? Well, we can do it via multiplication, or we can do it division. Now I encourage using a calculator. Calculators are fantastic. So if this is my right number, this is my left number. I'm going to do a quick little thinking bubble here. I'm going to do my right divided by my left. You can write it this way. You can write it as a fraction. And again, using my calculator, which I need to find and locate. So I have 8/3 divided by 4. Now in my calculator, make sure that you guys are putting the fraction, the 8/3, in parentheses, or else it won't work out. And that gives me 2/3 as my answer. And you want to make sure you keep doing that. So now I'm going to take my next right and my next left and keep checking them to make sure that you do have a pattern. So again, in parentheses, I have 16/9. I'm going to divide that by, in parentheses, 8/3. Make sure you guys are putting in your parentheses. And again, I get 2/3, which again, I'm doing a little mini happy dance because it's the same Therefore, I, check one more time for this one. To save time, I won't do it, but go ahead and check it. And so my common ratio, my r, my little r, is 2/3. Now, how would this work if we were to do the multiplication, find the pattern this way? If I use multiplication to find the pattern, all I have to do is say my left times what equals my right. So my left is 4 times what equals my right, which is 8/3. This would be your little r. This is your common ratio. So how would we do that? Well, we would divide by 4 on each side, which obviously is what we did here. Now, when you have fractions, I actually recommend starting out with the two fractions next to each other. Like, don't start out with this. Start out with maybe these two. So I'm going to start out with 8/3 times what is equal to 16/9. It's a little bit easier to do it this way because now I can see that 8 times something is 16, 3 times something is 9, 3 times 3 is 9, 16 times 2, 8 times 2 is 16. So then automatically you see that you have 2/3 as your little r or common ratio. So you can do it both ways, whichever way works for you. Understand that they are the same thing, you're just solving an equation, right? You're just solving what r is here, and you're just solving what r is there. So for our geometric formulas, we're going to have two formulas just like we did with our arithmetic sequences. We're going to have explicit and we're going to have recursive. And just like before, recursive are the formulas that depend on the previous term. For example, if I want to know what number is in the 24th position, then I need to know what number is in the 23rd position. And if I need to know what number is in the 23rd position, I need to know what number is in the 22nd position. So the formula depends on the previous term. So recursive is not something that we typically use just because it takes a long time to work with it. We're going to be working with explicit more. You just still need to be aware of the recursive rule. My recommendation is always create a cheat sheet for the for the unit. So start any sort of formulas that I provide or that you notice, just write it on that sheet of paper. And so whenever you have any homework or any questions that come up, you can always look back at that cheat sheet and have everything listed out for you. You definitely will need that. All right, let's go ahead and start with the explicit rule for the geometric sequence. Now this one's starting at 0, so that means the position number starts at 0. So when we have a sequence, the first number that you see is going to be in the 0th position. The second number you see is going to be in the first position, and then so forth. So the formula for that is going to be a sub n equal to a sub 0 or a naught times r to the n power. Now again, this is for n greater or equal to 0. Sometimes you're going to see this formula written out a different way. Instead of a sub, you're going to have f of. So sometimes you're going to see that formula written as f of n is equal to f of 0 times r to the n power. It doesn't matter which one you use, however, in class, we're going to be using a sub more often than f of. All right, let's go ahead and do our formula for the explicit rule starting at 1. So that means that when we have our list of numbers, our sequence, the first number you see is in the first position. The second number you see is in the second position, and the third number you see is in the third position, etc. Okay, so the formula is a sub n is equal to a sub 1 times r to the n minus 1 power for n greater or equal to 1. And let me give you the other formula. F of n is equal to f of 1 times r to the n minus 1 power. It doesn't matter which one you use, however, we will be using this a sub n more often than f of. All right, let's go ahead and do our recursive rules. For starting at 0, I have a sub n is equal to r times a sub n minus 1, where a sub naught or a0 is something for n greater or equal to 1. Let me explain this. This term, let's say a sub 24. So we want the term in the 24th position. This is our common ratio. This is our pattern. So our pattern times 24 minus 1, 23rd. So this is the 23rd term. So the number in the 23rd position times our common ratio is equal to the number in the 24th position. So in order to know what the 24th number is, we need to know the 23rd number. But how do we know what the 23rd number is? Well, we need to find out what the 22nd number and the 21st number and the 20th and etc. So when you have the recursive rule, you have to tell them where to start. So if we are starting at position number 0, you need to tell the reader in position 0, the number you will have is blank. So you will need to tell the reader what is in the 0th position. I'm sorry about that, you guys. For some reason, my computer glitched. I forgot what we were talking about, but let's go ahead and continue talking about this one here. So just like when we had recursive starting at position 0, now we have recursive starting at position 1. So in the first position, you have to tell the reader what number is in that position, because all of the other numbers depend on the ones that come before it. All right, let's go ahead and do some examples. We have 3 examples for this one. The 4th term of the geometric sequence, whose first term is 7 and whose common ratio is 5. So this one I didn't write what the actual question or prompt is, but this one is asking you to find the 4th term. Find the 4th term of the geometric sequence. So we want to know what the 4th term is. This is our unknown of the geometric sequence. What you're going to notice is they have to tell you, in these word problems, they have to tell you what sequence you have, because otherwise you don't know if you're using arithmetic explicit rules or you're using geometric explicit rules. So in this case, we know it's geometric. We know that the first term, which we're doing a little mini happy dance because they're giving us more information. First term is 7. And not only that, we also know the common ratio is -5. So how would we start that? So going back to our formulas, I'm actually going to put a star next to the one you're most often going to be using. You're going to be most of the time using this one. However, these two are always fair game. This one you're going to see less often, but they're also still in the game. Again, this one's going to be most oftenly used. This is going to be a little less, but then make sure that you have this one. All right, so we're going to write down the formula. So a sub n is equal to a sub 1 times r to the n minus 1 power. Now, the reason I'm writing this formula down is because we want to know what the 4th term is. The term in the 4th position. So here's 1, 2, 3, 4. So in the first position, we need the 2nd term, 3rd term, 4th term. That's what we want. We want this one here. We don't know what that is. However, we do know that the first term is 7, and that our common ratio, what we're multiplying by, our pattern is -5. So if you wanted to, I mean, you can just use your calculator and figure this stuff out. I mean, it's really not that bad when you're being asked something of smaller numbers. So I have -35. Let me change my color. And then we're going to multiply by -5 again, which is 175, and multiply by -5 again, which is 875. So a sub 7, just kidding, a sub 4, I can save it, is equal to 875. So the term in the 4th position is negative 875. Now, I'm also going to do it the other way because on a quiz or a test, I'm not going to be asking you to solve something in the 4th position. I'm going to be asking you to solve something in the 85th position. So you have no option except to use the formula, or else you're going to be sitting there doing this for, I don't know, like 10 minutes. So let's do the formula. The a sub n, we're going to do a sub 4. The term that we want is in the 4th position. So I need to solve for the 4th position. A sub 1 is the first term. So what is in the first position? 7. What is our common ratio? We said our common ratio they gave us is negative 5. And now the n's always match. So you see how you have an n, the n became 4. You have an n, the n became 4. You still have that minus 1, but your n's are changing. That is the term you want, the position number you want. Okay, so let's go ahead and continue solving this. This a sub 4, there's nothing to do with that. There's no arithmetic, anything for us to solve. This is what we are solving for. On this side here, please make sure that you are following PEMDAS. Please excuse my dear Aunt Sally. So you're going to multiply after you have evaluated your exponent. 4 minus 1 is 3. So I'm going to have negative 5. Negative 5 to the 3rd power, I get negative 125. After you have evaluated your exponent, then multiply, and you get negative 875 as the term in the 4th position. All right, moving on to example number 2. Find the 6th term of the geometric sequence. And I didn't give you the geometric sequence, so let me write this down for you real quick, because we can't really do anything unless we know what the numbers are. So I have 1/2, I have 3/2, I have 9/2, etc., etc., etc. And again, they want the 6th term. So this is my a sub 1, so my number in the 1st position. This is my a sub 2 number in the 2nd position, 3rd position, and they want to know what the number is in the 6th position. So we can find out the pattern and continue doing it. Again, on the test or quiz, I'm not going to give you something in the 6th, 4th position. I'm going to give you something in the 24th position, something a little bit more challenging. So what you're going to do is you're going to start out again with your formula. A sub n is equal to a sub 1 times r to the n minus 1 power. Now that we're here, we're going to replace what we have and what we want. We want the term in the 6th position. My first term is a sub 1, which is 1/2. And my r, we don't know that yet, but I do know my n, we want the 6th term. So it's going to be 6 minus 1. So let's figure out what the r is. It is your choice, again, to either divide or to multiply. I'm going to choose to multiply. I'm going to say 1/2 times something is equal to 3/2. Noticing that the 2's stayed the same, so I'm going to say I multiplied by 1. Now the 1 became a 3, so 1 times 3. I'm going to try that again with my other number because we have to make sure, verify that we in fact have a pattern. And just second time around, it makes it easier. In fact, it is 3. So my common ratio is 3. Now you're going to do PEMDAS, simplify, and evaluate. So I have 3 to the 5th power times 1/2, which is equal to the term in the 6th position. 3 to the 5th power, that is 243. I'm going to multiply that by 1/2. And that gives me a fraction. And that's okay that it gives me a fraction. It doesn't have to be perfect. That's just the number it is in the 6th position. So in the 6th position, I have 243 over 2. Let's do one more example. If the second term, well, let's do some highlighting. I encourage highlighting, underlining when you're dealing with word problems. It helps. The second term is negative 4/3, and the third term is 8/3. What do we want? We want a sub 1 and we want r. So I'm going to draw this out. If the second term, so here's term 1, so here's a sub 1, here's the second term, so a sub 2. If the second term is negative 4/3 and the third term, a sub 3, is 8/3, find what a sub 1, or the first term, and our common ratio will be. So again, let's do a little thinking bubble here. I'm very happy that these two are next to each other. If they are next to each other, we can find out what the common ratio is. So we have negative 4/3 times what gives me 8/3. I'm again noticing the 3's are the same, so I'm going to be multiplying by 1 in the denominator. And then for the numerator, 4 times what is 8? 4 times 2 is 8. However, I am noticing that the negative goes away, so my 2 has to be negative. You can always do the division, take your right, divide it by your left, use a calculator as well. So that means my common ratio is -2. And we need to find out what our first term is. So if my pattern tells me that I'm going to be multiplying from my left to my right, we're going to do the opposite of that to find out what the previous term is. So to go from my left to my right, I'm going to be multiplying by 2. So what we're thinking of now is what times -2 is -4/3. So we need a 3. Remember, we had that 1 in the denominator. So I'm going to have a 3 in my denominator because 3 times 1 is 3. What times -2 is 4, and that is 2. So in my first position, I have 2/3. All right, beautiful people, this wraps up this video. I hope you enjoyed it and learned a lot, and I will see you in my next one. Bye.